In this video, you and I get to take a look at doing redistribution to cause our imports and exports to happen between a VRF and BGP. Let's jump in. Here are the opt-out questions for this video. What a lot of people enjoy doing is they'll go through a video, have a great time, learn a bunch of stuff, and then come back to these opt-out questions just to gauge their understanding and see how much progress they're making as we go through the videos together. So I offer that recommendation to you as well. It's a great way to gauge your understanding and to see your progress in our journey through the world of MPLS. So, having said that, let's continue. I'd like you to imagine with me three simple routers: router A, router B, and router C. And we've got some basic connectivity. For example, A is connected to B, and B is connected to C. And maybe A has a network over here of 10.5.0.0/16. And maybe router C has a network of 10.6.0.0, also /16. Let's say also that we're running some routing protocols. Let's say, for example, running OSPF for the 10.50 network and the network that's connecting A and B together. So we'll label that OSPF. And let's say we're running RIP between router B and router C, which includes the 10.6 network. Now here's my question for you. How is router C, way over here on the right, inside of RIP, and I'll label that as well, how is that going to learn about the 10.5 network? I mean, router C is not running OSPF. And on the other side, how is router A ever going to learn about the 10.6 network? Because router A is not running the RIP protocol. How are they going to learn about each other's routes? And there may be, for example, hundreds of routes. How do we get those routes over into the other routing protocol? And the answer is we're going to do something called route redistribution. And it goes something like this. We would go into RIP configuration and say, I want to redistribute all of the OSPF routes into RIP. And we would go into OSPF configuration mode and say, I want to redistribute or pull all of the RIP routes into OSPF. And so router B would be doing bidirectional redistribution of one routing protocol into the other and vice versa. And that way, the 10.6 network would now be in OSPF and router A could learn about it. And the 10.5 network would be put into RIP so router C could know about it. And that's the basic concept of redistribution. Now let's apply that to our topology at hand. We've got OSPF here in the VRF between ACME and R1, and we have border gateway protocol running between R1 and R5. And we've already identified that we need to do exports of the routes out of the VRF into BGP. And we also need to do imports from BGP into the VRF. So if you recall the diagram that I had you write out in a prior video, let's write it out again. That's with the VRF here. And it is the center of the world regarding the concept of importing and exporting. If we're taking routes out of the VRF and we're putting them into BGP, it's an export. Again, from the perspective of the VRF. If we're taking routes out of BGP and we're putting them into the VRF, that would be an import. So down here in R1, where we have OSPF routes and we have BGP, if we want to make the import and export happen, we need to have R1 do mutual redistribution. So we'll go into BGP configuration mode and we'll say, I want to redistribute the routes out of the VRF's IGP. In this case, it's OSPF. So in BGP configuration mode, when we say, please pull those routes out of the VRF and put them into BGP, that would be an example of doing an export. Now, on the other hand, if we want to take the routes out of multi-protocol BGP that match the route targets for that VRF and pull them into the VRF, that would be an import. If we're running OSPF, we would go to OSPF configuration mode, and we would say, I want to redistribute or pull in all the routes from BGP. And then it will consider all the routes from BGP, and any of those routes that have the route target that matches the import route target, those routes will be brought in to the VRF. So in our example for ACME on R1, the OSPF configuration would be for imports because we're pulling in the BGP routes, and the BGP configuration, where we're redistributing OSPF into BGP, that's where we would configure our exports. Now when we're doing these imports and exports, instead of BGP, we don't want the global routing tables implementation of OSPF. We just want the VRF's OSPF. So we have an address family just for that. And when we go into OSPF to pull the BGP routes into OSPF for the import, we aren't going to use the global routing tables OSPF. We're going to use the OSPF process that's allocated and assigned to the customer's VRF. So the redistribution is going to be done very specifically so that they focus just on that customer's VRF for the import and the export. And so what we get to do together is I'll walk you through step by step those exact commands to do that for R1 as we import and export between OSPF and BGP, and for CBT as we import and export for EIGRP and BGP, and then over here on R5 as we import and export between BGP and RIP. Now the cool thing is this, because we used Border Gateway Protocol already between R5 and CBT at Site 2, we don't have to do any type of manual redistribution. It will automatically redistribute between VPN v4 routes and the VRF IPv4 routes. So what you and I get to do together right now is walk through these steps. We'll start on R1 with a focus first on Acme Site 1 and its routing processes. I'd also like to point out that all of this redistribution is all done in the mind of our provider edge routers. The customer is completely unaware of any of the magic that we're doing. The customer doesn't implement or use VRFs in our topology. The customer is not doing any type of redistribution. It's all happening inside of our provider network, specifically at the provider edges. So we are going to start by exporting routes from the Acme VRF into BGP. So before we begin, let's just take a look together at what we currently have for our router BGP configuration on R1. So we have our basic IPv4 stuff here. This is the VPN v4 capabilities between R1 and R5. And what we're going to do is we're going to add a section into router BGP, and that'll be for address family, for IPv4, which is just basic normal IPv4 routes, for VRF 101 Acme, and then we're going to say redistribute from that OSPF. Now the actual syntax will include the OSPF process and the name of the VRF we're pulling it out of, but that effectively is the export, because we're taking it out of the VRF for Acme and we're going to pull it into multi-protocol BGP. Now here's what we get to be clear on. When we pull those OSPF routes related to that VRF and we pull them into BGP, we're doing that export, that's the moment they become VPN v4 routes. And I'd like to do a quick review with you of what's going to be included as part of being a VPN v4 route. It's going to have the IPv4 prefix information. So let's say we have 172.16.111.2. That is the loopback address on the router at Acme Site 1. It's being advertised to R1 via OSPF for that VRF. And with the redistribution that we're about to do, it's going to pull that route and any other routes that come in. And for each route it brings into BGP, now as a VPN v4 route, it's going to add a route distinguisher. So in the VRF, that route distinguisher we set up on R1 was 1.1.1.1:1. So the route distinguisher will become part of that information as a VPN v4 route. It's also going to have a route target associated with it. Now the route target is assigned at the time we do the export out of the VRF, and it's based on whatever the export route target is for Acme's VRF. So on R1, we set up the export route target as 1.1.1.1:101. And I specifically made those different. They could be the same exact values. The route distinguisher is X and the route targets are all X. But I wanted to make them different so that when you see them and when we look at them together, you can clearly identify one from the other. Another component that will be added as part of this VPN v4 route is something called the VPN label. Now in R1 we said you may use Mr. R1 for the purposes of education only the range of 100 through 199. In a production environment we need a whole bunch more labels, and that's because this is only 100 labels. If we have 1,000 routes, guess what? We're going to need 1,000 labels. So in our environment we're not going to have more than 100 routes, so this is fine. And once we turn on this exporting of the OSPF routes into multi-protocol BGP, R1 is going to choose a label. Let's go ahead and pick number 172. Now I'm just making it up at this point because the router gets to choose what that label is going to be. And if we ask this router, dear Mr. R1, what is your MPLS forwarding table for the VRF called Acme? It would show that to reach 172.16.111.2, it has a local label of 172, and the next hop and all the other details about how to forward that packet would be cached inside of Ceph and ready to go. Now between R1 and the customer edge Acme at Site 1, if we looked at the MPLS forwarding table for that VRF, it would show us that the local label for this network 172.16.111.2 is 172, but it would also show that for forwarding it would use no label, meaning it's not going to impose a label and send it up to Acme at Site 1. It's simply going to send it as a raw IPv4 packet. It's going to pop all the labels off and simply send via IPv4. Now this is also really cool because if some device forwarded to R1 a packet, an MPLS labeled packet, and it said, hey, by the way, this 172 is the VPN label, it would already know how to forward a packet. So if it received a VPN label of 172 inside of Ceph, it's all cached, ready to go, it would take off the label and forward the packet over to Acme at Site 1. Now none of this is actually really going to happen unless we configure the redistribution. So let's go ahead and do that right now. To do that, we're going to go into router configuration mode for 65,536. We're going to go into the specific address family for IPv4, for VRF 101:ACME, and we're going to say, please redistribute, pull all the OSPF routes from process 101, which is part of VRF 101:ACME. So at this very moment, as we speak together, it's added the route distinguisher based on the definitions for ACME's VRF. It's added a VPN label that it pulled out of thin air between 100 and 199. It was its choice. It attached the route targets that were associated as export route targets in the VRF for ACME. Now you might say, okay, Keith, how would we actually verify that? And that's a great question. Let's take a look at some ways we can verify those details regarding the now VPN v4 routes that we've just exported out of OSPF for ACME and into BGP. What we could do is this. We could simply ask the router, please show us all the VPN labels for route distinguisher 1.1.1.1:1. So here's the request for the VPN label information based on that specific route distinguisher inside of BGP, and said, sure enough, no problem. It's showing us that we have two VPN routes inside of BGP. The network 101, to which we are directly connected, we assigned the label of 107, and the loopback address. This is the loopback address, the 172.16.111.2, that's sitting on ACME at Site 1 and being advertised to us via OSPF. We chose to assign the VPN label of 108 to that specific prefix. And if we have 20 or 30 different routes inside of the VRF in OSPF for that customer, we would have 20 or 30, the same number of labels, one per prefix. Now, what I'd like to do also is show you a couple of different ways to issue effectively the same command. In this example, we're doing a show BGP VPN v4 unicast based on the route distinguisher of 1.1.1.1:1. Please show me the labels. Now, in implementing these commands, we could use these three words, IP BGP VPN v4, or these three words, BGP VPN v4 unicast, and most routers are going to support both. They're backwards compatible with the older set of commands. But the reason I point them out is that if you have a force of habit of doing a show IP BGP, you can usually get the same output as you can by using the show BGP without the IP in front of it and include the word unicast after VPN v4. So what I'm going to opt to do in our course together is I'm going to use most of the time show BGP as opposed to show IP BGP. But again, that's just a preference. If your router supports both, please feel free to use either one that you're most comfortable with. And the way you're going to get comfortable with these commands is, you got it. You're going to practice, practice, practice with these commands. Because you never know if you're going to be at a customer site and they've got an older version of iOS that only supports one of these flavors. You're going to still want the ability to run the show commands to see the information regarding the labels. Now, another way we could ask for the same information is say, instead of searching for the route distinguisher 1.1.1.1:1, I want to see the labels for just VRF 101:ACME. And because they're exactly the same, that's the route distinguisher we're using for that VRF, the output's going to be the same. So in these last two commands, I simply swapped out VRF and the name of the VRF versus route distinguisher and the number of that route distinguisher. So anything you want to search on is completely okay. Now next, just for fun, let's go ahead and take a look at the MPLS forwarding table for the VRF called 101:ACME. And let's focus on just this one route for a moment, 172.16.111.2. That's that loopback up on ACME 1. This is R1 saying my local label is 108. We already knew that. That's the local label. So for example, if somebody sent a VPN label of 108 to this router, he would say, great, here's what I'm going to do with it. I'm going to go ahead and forward it. Here's the next hop of who I'm going to send it to. That's ACME at Site 1. Here's my egress interface I'm going to use. I'm not going to use any labels because our customer edge is not part of any type of a label switching path. And this V right here represents that it's a VPN label. So in the mind of R1, if it received a packet, an MPLS packet, and it had a VPN label of 108, R1 would know exactly what to do with it. In fact, we can verify that with a show IP Ceph for our ACME VRF, specifically looking for the details regarding that loopback interface on Acme Site 1. So what this says regarding that network, we're going to go ahead and forward it out fast Ethernet 2/0. Same information we had up here. And our next hop is 172.16.101.2, which is the IP address of our Acme Site 1 router. And if we wanted to see all the VPN v4 routes that were associated with the VRF called 101:acme, we can simply ask for it. So here's our command, and as far as the VPN v4 routes that we have, here's our two prefixes. Again, they're the same two prefixes that were up here. They both have a VPN label locally associated with those networks. And the next hop information hasn't changed either. So this is the IP address of Acme at Site 1, and 0000 implies that's us. We are directly connected to the 172.16.101 subnet. And if we wanted to take a closer look at the details regarding a specific route, maybe that loopback address 172.16.111.2 that's in our BGP table, we can simply ask it with this command. So we've added on the specific prefix we're looking for, and check this out. Look at this information right here. This is the network layer reachability information. The first numbers, 1.1.1.1:1, that's our route distinguisher. And the next number is the actual network/mask. So there's the RD being shown. And down here, if we look at the extended community values that are associated with this route, I'd like to focus your attention on this guy right here, which is route target 1.1.1.1:101. It's also representing right here the label that it has associated with that. So if it received a VPN label of 108, it would go ahead and forward it, but it would not have an outgoing label. And that's because our neighbor, which is Acme Site 1, isn't participating as part of our label switch path. It's simply an IPv4 customer edge router who would be the next hop if we received a labeled packet of 108. So that was all about the export and 5 or 6 different show commands to verify the different pieces of what happened as a result of that export. Now we still need to do the import of routes from BGP into the VRF for Acme. So to do that, we're going to go into router configuration mode on R1 for OSPF 101 for VRF 101:acme and simply say, I want to redistribute from BGP Autonomous System 65536 and I want to redistribute all the routes, not just the classful ones. So what's going to happen with this, based on the route targets in the routes in multi-protocol BGP, we set up the import route target on Acme to be 5.5.5.5:101. So if or when we see any of those routes in multi-protocol BGP that have that extended community of 5.5.5.5:101, because that's what our import route target is looking for the VRF, it's those routes inside of BGP that will come in to our OSPF for Acme. So the game with that is that any routes up at Acme Site 2 that get advertised down to R5, R5 has an export route target of 5.5.5:101. Then that VPN v4 route is advertised over to R1. And then because this route target on that VPN v4 route matches what the import route target is for Acme's VRF, and because we're doing this redistribution to tell it to try to bring those routes into OSPF, which is an import, that would cause the routes that were initially sourced by Acme Site 2 to now show up in the routing tables of Acme Site 1. The next thing that I'd like to do is let's go ahead and do an export for the benefit of CBT's VRF. So just for a moment, I want to take a look at what the current configuration is for Border Gateway Protocol. So here's the export information for Acme's VRF. So what we're going to do for CBT is we're going to follow the same kind of a process. We're going to go back into router configuration mode for BGP, Autonomous System 65536. We're going to go specifically into address family IPv4 for VRF. In this case, it's going to be 102:CBT. And instead of pulling the routes out of OSPF, we're not running OSPF in the VRF for CBT. So we're going to go ahead and pull the routes out of EIGRP, Autonomous System 102, because that's where the routes for CBT Site 1 are. They're in EIGRP, Autonomous System 102. That's the one that we associated with that VRF. So we'll just go ahead and do it. We'll go into router config, we'll go into the address family for that specific VRF and say, please pull the EIGRP 102 routes out and put them into BGP. That is the export function for the CBT VRF. We're taking the routes out of the VRF and we're pulling them into Border Gateway Protocol. Now I have a question for you. Do you recall what the additional information will be that's going to be tagged on to these routes as they're exported out of EIGRP from the VRF for CBT and into BGP as VPN v4 routes. So what I'd like you to do is think about that for a moment and see if you can identify 2 or 3 things that are going to be added on. Now if you're thinking, Keith, I got this. We're going to have a route distinguisher. The route distinguisher associated with the VRF for CBT, that route distinguisher is going to be tagged on as a VPN v4 route. Awesome, check. What else gets added as a VPN v4 route? So you might be saying, well, whatever the export route target is associated with the CBT VRF, that route target as an extended community will also be added to that VPN v4 route. That is awesome. What's one more thing that's really important also that's going to be added as part of the VPN v4 route? The route distinguisher, the route target. What's that last one? And if you're saying, Keith, I got this, it's the VPN label. So if you have a network like Network X, that Network X is going to have a VPN label associated with it. And all of that information is going to be included as part of that BGP VPN v4 route that can then be advertised over to R5. So let's take a look at our full BGP configuration here, just so we have a nice picture of all the pieces. We'll do a show, run, section BGP. Here we have the export for Acme. Here we have the export for CBT. We have this portion here, which is just for the multi-protocol BGP support for VPN v4 routes between R1 and R5. And this section right here is really for IPv4 support. And we could actually disable the sharing or capability of sharing IPv4 routes if you're not using them. So let's take a look at some of the details. Let's do a show BGP VPN v4 unicast for VRF 102 CBT. Let's focus on this one first, the 172.16.222.2. That is the loopback address on CBT Site 1 that's being advertised via EIGRP over to R1. And because we just did the export out of the VRF into multi-protocol BGP, that's why it is a VPN v4 route that we're looking at. It shows us the next hop, and this is the IP address of the Ethernet interface at CBT at Site 1. And it's also showing us these 2 routes right here. Check that out. We have some 192s. Now these 192 routes are coming over from CBT at Site 2. And that's because if we use BGP at the edge with our customer, the redistribution into VPN v4 routes happens automatically. And that's why these routes are showing up right here. If we weren't using BGP over between R5 and CBT at Site 2, we would not automatically just have those routes showing up as VPN v4 routes that we've learned from 5.5.5.5. That's R5's address. So I'd like to focus just for a moment on that prefix. That's the loopback that's being advertised to us by CBT at Site 1. If we want to see the VPN labels involved, we can say, please show us all the labels associated with the VRF called 102:CBT. So for this network, 172.16.222.2. So regarding this IP address, which is that loopback on CBT at Site 1, R1 chose to use a label of 110. So 110 wasn't in use, and that's the label it generated of 110. If we look at the MPLS forwarding table for the same VRF, CBT, the 102:CBT, it would show us exactly what it would do if it received a packet that had the label 110. So again, focusing on the loopback of CBT at Site 1, the VPN label that we've locally generated is 110, and if we received a VPN label of 110, what would we do? And this is saying we would go ahead and forward it. Our next hop would be 172.16.101.2 out of FA2/1, which goes over to CBT Site 1. It's also indicating here that that is a VPN route, a VPN v4 route, which would make this a VPN label. And just to confirm that, if we did a show IPsef for VRF 102:CBT for that specific prefix, it would say, sure enough, here's exactly what I'm going to do. If I got a packet destined for 172.16.222.2, my next hop would be 172.16.101.2. I'd use the fast Ethernet 2/1 as my egress interface, and I would forward the packet. Now, even though we have these networks of 192 that have been kindly advertised from good old R5, we, meaning R1 specifically, R1 has not begun to advertise those into EIGRP, and as a result, CBT at Site 1 does not yet know about those routes. We need to finish the config and do our import. Because if we do the import, where we redistribute BGP into EIGRP, based on the route targets matching the VRF, that will then allow those routes to get inside of EIGRP. So as an example, let's go over to CBT1 just for a moment. And on CBT1, let's do a show IP route. And really, CBT1 knows nothing except for directly connected networks. He's got his loopback, he's got FA2/1, and that's it. However, when we go back to R1 and we finish off the config by importing the routes from BGP into EIGRP that will then allow CBT1 to learn about those routes and add them to its routing table. So on R1, we'll start by going into configuration mode. We'll go into router configuration mode for EIGRP1, and then we're going to go in that separate room, the address family for our specific VRF called VRF 102:CBT. And so for this VRF, it's using the Autonomous System 102 for its EIGRP related functions. And now that we've moved into this address family configuration mode, regarding EIGRP4, the specific VRF, we can now do the import, which is pulling the routes from BGP into EIGRP. And with EIGRP, we do need to set a metric. There isn't a default one set by default. So all we're doing here is we're simply saying that for all the metric values, we're going to put a 1 in all those positions. And with the metric of 11111, because one of those values is actually the bandwidth available, we're going to have a really huge or poor metric. However, we're not competing with a whole bunch of other sources for that same network. So even if the metric is terrible, as long as it's still reachable, that route can be used. So let's exit out of configuration mode and let's go pop back over to CBT1. So a moment ago, we didn't have any EIGRP learned routes. If we use the magic up arrow key and press enter, so now we have a couple of EIGRP learned routes. We've got the 192.168.202, which is a /30, and we've got the 192.168.222.2. So this one right here happens to be that loopback address over on CBT2 that's being advertised over to R5, who put it in as a VPN v4 route, and then R1, because of the import, pulled it out of BGP because of matching route targets. And with that redistribution into EIGRP, it now is advertised over to CBT1. And now he has those routes. So for each VRF, we're doing the import and export game between BGP and the IGP that we're using for that VRF. So we have one more customer edge that we have to manually configure redistribution for. And so we'll go over to R5. So what we're going to do is we're going to go into router configuration mode for BGP 65536 here on R5. And we're going to go into address family for the VRF called 101:ACME. And then we'll simply say, I want to pull the RIP routes into BGP. And that's the export. So we're exporting from the VRF's RIP process into BGP. So we can exit out just for a moment. And now let's take a look at our labels. We'll go ahead and do a show BGP VPN v4 unicast for VRF 101:ACME labels. So regarding our local labels for 192.168.111.0, we've got a local label of 509. And the reason I'm chuckling is because that is the loopback interface up on Acme Site 2. And it's actually a 32-bit address, but it's showing up here as a 24-bit route. And I think the reason for that would be that Acme at Site 2 in RIP, I probably left auto summarization on. So it's summarizing it to a classful boundary before advertising it. So let's verify that for a moment. Let's go up to Acme and say, please show me your IP protocols. And I'll bet you it does have, and there it is right there. It has automatic network summarization is in effect, and that's why it's summarizing the loopback address. Well, we can fix that. So on Acme Site 2, we'll go into configuration mode, and we'll simply say, please don't do auto summary with the no auto summary command. And now we should be advertising a 32-bit route via RIP, which is now being redistributed into BGP because of the export that we just did. So let's go back together over to R5. And on R5, let's use the up arrow key and take a look now that we do have the 32-bit route. And check it out. There it is. So it treats it as a new route because it is a new route. So if we wait a few minutes, RIP will converge and drop the old /24. But meanwhile, it's hanging on to it, so there's a label for it. But here's our new 32-bit route right here. 192.168.111.2 with a /32. And the new label that we've assigned to it is 511. So that is our new VPN label that we've associated with this specific prefix for this VRF. So that is the export that we did out of RIP into BGP. And we also need to do the import so that we're taking routes out of BGP and putting them into RIP, presuming that the route targets in those VPN v4 routes match the import route targets in the VRF for Acme. So we'll go into configuration mode. We'll go into router RIP for address family IPv4 for the VRF called 101:ACME and say, please pull the routes from BGP 65536 and let's set the metric to 5. And it's just a number that I pulled out of the air. So with RIP, you have a maximum hop count of 16, or 16 is infinite. So if you bring them in at a 5, they're not going to be a great route, but they're also not going to have a hop count of 1. There's also an option of using the keyword transparent instead of specifying what the hop count should be. So now if we go to Acme Site 2 and we do a command, for example, like show IP route, here we have 2 RIP learned routes. Now these 2 routes are the routes that are being sourced from the top left-hand side of our topology over by Site 1 for Acme. You'll notice that we have RIP as the source. That's how they came in to Acme at Site 2. They've got the administrative distance for RIP, and they've got a hop count of 5. Because that's what we set it to when we did the import, the redistribution from BGP into RIP. And we have the next hop of 202.1, which is the IP address on R5 that's associated with the interface that's allocated to the VRF for Acme. Our next thing we definitely want to do is save all of our configs. So I'm going to go to every single device, even the ones I didn't touch, save my configuration on every single one. Then I'm going to bring up GNS3 and make sure I save that project as well. I strongly recommend you do that along with me. In this video, we focused on the redistribution, both ways, bidirectionally, between OSPF and BGP, EIGRP and BGP, and RIP and BGP, because that redistribution is going to trigger the import and export functions between the VRFs and Border Gateway Protocol. Now, the actual commands that I used in this video, I have made part of the Nugget Lab files. So I'd strongly recommend you download the Nugget Lab files, take a look at the script for this specific video, and then practice it. It will take a few times of practicing it to become more and more comfortable with the commands for the imports and the exports. I'd also strongly recommend you write out that VRF with the 2 lines. Going out of the VRF is an export, which we configure inside of BGP configuration mode. And when we're taking routes into the VRF as an import, we do that configuration inside of our IGP. And inside of the respective routing protocols, we're going to use the correct VRF-specific commands to implement that redistribution between the IGP and Border Gateway Protocol. We've also taken a look in this video at a few of the commands on the PEs to verify that that redistribution from IGP into BGP and back and forth is happening correctly. Your mission, should you choose to accept it, is to practice everything that we've done together in this video. Now, to assist you to that end, I've included the commands I've used in this video, including the show commands, as part of the Nugget Lab files. So they're there as a resource for you as a member. Just download the Nugget Lab files, and then you can use that as you walk through step by step in implementing the BGP to IGP redistribution in your own practice lab. The other thing I'd love for you to do is go take a look at the opt-out questions now that we've gone through this content together to kind of gauge your understanding and see how much you've improved regarding the concepts that we've identified and learned about in this video. And in our next video, I'm so excited for it as well, because in our next video, we're going to take a look at how all these pieces fit together, including the VPN label and what happens on the data plane if somebody at Site 1 does try to forward a packet over to Site 2. So I look forward to seeing you in the next video. Meanwhile, I hope this has been informative for you, and I'd like to thank you for viewing.